Hello, welcome to our series of videos about coastal processes and coastal environments. So this is following the AQA GCSE specification, and what we're going to do is we're going to introduce you in this video to the different things that happen along the coast, in particular the different types of waves and the characteristics of beaches and coastlines according to the different types of waves that we've got. So first of all, you've got on your screens a diagram. You may have seen this diagram in science. Remember, it's important to draw parallels and similarities from different subjects together. So I know that this is something that is taught in physics when you're talking about waves. So waves in a sound sense or waves in a water sense are very similar processes that are going on. And so we use very, very similar terminology. So in terms of our waves at a coastal environment, we have here a diagram. As you can see, it's a very simple diagram, and it's showing a wave crashing onto a beach area, which is the yellow bit. What we've got in this wave environment is we've got wave crests. So wave crests are basically the top of a wave. A crest or a peak is the top of something. So when you go on field work, you might go up to an upland area, and you might go onto a crest of a ridge, so it's the top. The highest most point. So that's what a wave crest is. It's the top of a wave. You've then got a wavelength. A wavelength is the distance between two crests, and that is going to help you later on to understand the frequency of a wave and how often it actually comes into shore. So the wavelength is quite important. The shorter the wavelength determines what type of landforms we're going to get and what types of processes are going on. We've then got the wave trough, and that's basically the lowest point on a wave. It's normally in between two crests. It isn't necessarily right in the middle of two crests, but it is in the middle somewhere between the two crests. So it's the low point. The wave height is the difference between the crest and the trough. So the wave height again is important to look at later on when we're looking at different landforms and erosional processes, because if you've got a higher wave height, there's going to be more potential energy compared to a wave that's got a lower height. You've got something called swash, which we will talk about a lot. Swash is where you're swashing things or washing things up the beach. Material from obviously in the sea. So you can see this when sand is pushed up the beach. If you ever stood on the beach where the waves are breaking, and the sand kind of washes between your feet as it's going up the beach. So that's swash. We've got a breaking wave. Obviously, waves break. Typical pictures of waves, you'll see them crashing down, and white tips of the waves as they crash down, that we call a surf. And so, depending on how high the wave is, depends on how it breaks, whether it's going to have a real crashing down type of break or just a gentle push of water in onto the shore. Just to go back again, in terms of swash, there is an opposite of swash, which you can see here, which is called backwash. Now, a backwash is where the water is taking material off the beach. So sometimes you might get a scenario where swash is greater than backwash, or backwash is greater than swash, and that'll lead to different types of beaches, which we'll look at in a moment. There is one other thing we haven't mentioned from these terminologies, which is fetch. Now, fetch is easier to understand if you are to consider a map of the world. So on a map of the world, if you look at where the size of different oceans and different coastlines of different countries, if a wave is coming from one side of an ocean to another, it's got a large fetch. So a fetch is basically the distance over which the wave forms. So the southwest of England, down by Cornwall, where a lot of surfers go in a place called Fistral Bay in Newquay, because it's got really good waves. It's got good waves because it's got a really long fetch, that stretch of ocean. So it's the Atlantic Ocean, and the fetch is all the way from the United States of America right the way across. So that's the distance that the wind blows to create that wave. So waves are not created by the moon. We'll talk about this in a minute. Waves are created by wind pushing the tops of the waves. And we'll look at that, as I said, in one moment. So we were talking about the different terminology and characteristics of a wave. But there are two different waves that we've got. So we've got constructive waves, which is the top diagram. A constructive wave is where it's constructing something. If you think back to, or think to the plate tectonics hazards topic that you will have studied or will study, on there you've got constructive plate margins, and that's where something is being created. Construction, so to create. So a constructive wave is creating something. Now these waves are small wave height. They're not as frequent, so the wavelength is a really long wavelength compared to the other type of wave we're going to look at. And so it constructs beaches. The reason it constructs beaches is because the wave height is quite low and it's not as frequent, so you've not got loads of waves coming in all at once. It means that the swash is strong. It means you can get lots of material being washed onto the beach, which is really, really good to create a beach environment. So you need lots of swash, low energy conditions for that to happen. Because if you think about deposition, and that's what's needed to create a beach, you need low energy conditions. So you need these gentle waves. The backwash is very, very weak on these waves. There's still a little bit of backwash, but it's very, very weak. So not a lot of material is taken back off the beach. And it gives it what we call a gentle beach profile, which means it's quite a nice slope to walk into the beach. So you can imagine this if you've ever been to a beach. If you're walking into the sea, if you can walk for quite a while before it drops off, then it's a nice constructive environment. But if you walk and then it's all of a sudden a big drop off and it's quite steep to get into the sea, then it's the next type of wave which we're going to look at, which is a deconstructive or destructive wave. So these have got large wave heights and they're quite frequent. So instead of having a wave coming in every 5 to 10 seconds, you've got a wave coming in every few seconds, destroying things. That's why it's called a destructive wave. So the wave height is bigger, which means that it's got more potential energy, shown that by that red arrow. And because it's got more potential energy and more energy as it crashes down onto the beach, it means that not much material is swashed up and moved up the beach, but there's a lot more material that's taken away from the beach. And that creates a scoured, really steep beach profile. Because we've got this really strong backwash, so it's taking away material. That's why it's destructive. So as I said, the different wave heights will determine what type of wave you've got. Low wave height with not many waves coming in is constructive because it's allowing the beach to build up. Whereas if it's got high wave heights and it's really frequent waves, it's going to be constantly breaking away that beach and removing it. The reason waves break, I put this on because students tend to get mistaken between waves and tides, and I'll show you what tides are in a moment. But a wave breaks because of the change in the slope of the land. So waves are formed by wind. So I remember it, wave, wind, and because of the wind traveling across the ocean, it kind of whips up the top of the ocean. It causes, as it shows here in number 1, causes the waves to start to form out in the deep ocean. And they have what we call a circular orbit. So if you were to look underneath and see this happening, you kind of see a circular motion of the water. And that gives it a kind of a hump, a little bump on the top of the water that you'd see out in the ocean. As it approaches land, that circle can't be circular anymore because you've got land underneath it that's starting to squish that circle into what we call an ellipse or a rugby ball shape. And then as it gets further onto land, this ellipse starts to get kind of top heavy. And eventually the top of the wave will break over the bottom, and that's how a wave breaks. And depending on, as I said, the wave height depends on which type of wave we're going to get, depending on other conditions as well, which we don't have to get into for the GCSE. So how we get tides, so tides and waves are different. Tides are determined by the moon. You don't really need to know this in depth for your GCSE, but just to kind of understand, as the moon travels around the earth, it creates a gravitational pull which pulls the oceans, and as it pulls the oceans, that creates our tides. So Obviously, tides can influence what's happening on the beach, but ultimately it's the waves that we're looking at for formation of different things. So, just look at a few pictures in closing of this video. This wave here, considering that we've been through the characteristics of constructive and destructive, just for a couple of seconds in your head, what do you think this one is? And I'll give you the answer. So this is destructive, and the reason it's destructive is because you can see it's quite a high wave, and it's got really strong braking. Here, where it's kind of going over, that's the real strong break that will end up scouring the layers of material off the beach. This one here, much different. So constructive or destructive. This one's constructive because it's a lot lower wave height. You can see there's not many coming in at once, and because it's a low wave height, as you can see here, it's not going to scour away and take away loads of material. Where swash is greater than backwash is a constructive environment, because you've got more material being taken onto the beach than off the beach. If you've got short wavelength, high wave crests, and the waves are quite steep, the beach profile is quite steep, it's going to be destructive. So this is the destructive wave again. So I hope this has helped. If you've got any questions, please email your teacher or talk to your teacher. Thank you very much. Bye.